Good afternoon, everyone. Welcome to the session. So, in a previous lecture, we have covered the Prim's algorithm, right? One method we have seen. Now, today we are going to start with the second method, which is based on the algorithm. Okay, so let me share my screen and I'll tell you how this is exactly going to implement. Fine. So, everyone, please pay attention here only. Okay. So, the rules we are, first of all, we will talk about the rules, how we are going to proceed here. So as we have to build a minimum spanning tree, so first we will create a set, MST set, which is initially empty. Okay. So जब भी हम minimum spanning tree बनाएंगे, जब भी nodes हम उसको add करेंगे, right? वो nodes हम MST set में include करेंगे. Fine. Assign a key value to all the vertices in the input graph. Suppose in this graph, in this figure, we are having total 9 nodes. 0 to 8, there are total 9 nodes, right? Each node or each vertex, for each vertices we have to assign a key values. And what key values we have to assign? For starting vertex, we will assign 0. And for rest of the other vertices, we are going to assign a infinity. You have to find out which node is having a minimum value. If all the nodes are having an infinity, then how we are going to proceed? To start of an algorithm, we have to give the minimum value. That's why we will give one node as a 0 and rest of the other nodes as an infinity. Okay. After doing this, we have to check while MST set is not full, or we can say that if MST set is empty, then what we have to do? We have to pick a vertex which is not there in the MST set. Okay, initially MST set empty here, right? So to pick the vertex, you have to pick any vertexes which is having a minimum weight, and you have to check whether this vertex is present in the MST set or not. If it is not present in the MST set, then you have to include it, and then you have to update the key value of all the adjacent vertices of u. That means suppose सारे नोड्स मेरे पास है 0 to 9, ओके 0 to 8. 0 नोड के लिए मैंने क्या किया, 0 असाइन किया, रेस्ट ऑफ द अदर नोड्स आई एम असाइनिंग एज इंफिनिटी. अभी मुझे क्या करना है, इनिशियली एमएसटी सेट मेरा एम्प्टी है, फाइन. तो अभी मैं क्या करूंगी, मिनिमम कौन सा होगा, 0 वाला, राइट? सो आई विल टेक इट एज अ u 0 node, right? This is the node we are starting, 0th node we are going to start. अभी मुझे क्या करना है, u के एडजेसेंट में कौन सा है, 0 के एडजेसेंट कौन सा नोड है, नेबर नोड्स ऑफ 0 in this graph, 1 and 7, 1 and 7, right? I guess this is not visible to you. To do one thing, if you are having phone, then please join it through the phone. Otherwise, you are not able to understand clearly. This figure is not visible. Right? So 1 and 7 is the adjacent node. We have to check the distance of 0 to 1 and 0 to 7. Okay. So here you can see 0 is your start node, 1 is your destination node. Fine. 0 to 1. What is the distance? 4. Okay. 0 to 1 distance is 4. Then we have to check for all the vertices, we have to check the key value. If this distance is less than the key value, then we have to update the key value with this distance. Okay, these are the rules. Let me go through this example, how we are going to solve it. First of all, let me write down all the vertices. So here we are having vertexes 0, 1, 2, 3, 4, 5, 6, 7, and 8. Okay. What I will do is, for the zeroth vertex, zero number node, I will assign 0. Rest of the other nodes, I will assign key value as a infinity. Fine. I will assign key value as a infinity. For first node, we will assign 0. Rest of the other nodes, we will assign as a infinity. Okay. Now, next, what you have to do, we have to create MST set. Initially it is empty. Okay, initially we have not built any minimum spanning tree, so this set is empty. Now, how to include nodes in this and how to build the minimum spanning tree using Prim's algorithm? So here, first step is done. MST set we have created. Then we have assigned key value to all the vertices, right? Now we have to pick the vertices and we have to include in the MST tree or MST set. So where we will start? Now, check the key value of each node. Which one is minimum? Which node is having a minimum key value? Tell me. We have written vertices and its key value. Which one is a minimum key value? Now I'm asking about vertex and its key value. Vertexes and key value. Which vertex is having a minimum key value? Everyone tell me. Which vertex is having a minimum key value? Zero vertex, right? You have to look in this table. Okay. Now you just see. We have assigned each vertex is a key value. 0 is having a minimum value, so we will pick this as a U. U means your starting node. Okay. This is your U node. Now, next step. We have to check whether U is present in the MST or not. No, it is not present. So we can include it into the MST set. And then we have to find out the adjacent vertices of U. And we have to find out the distance. Okay. So let me write down here. U equals to 0. What are the adjacent nodes of 0? From the figure, tell me what are the adjacent nodes of 0? 1 and 7. Okay, so what I will do, I will write it down here, 1 and 7. And in MST set, I will include 0. Okay, now, what is the distance of 0 to 1? 4. What I will do here, just I will write it here. 0 to 1, distance is 0 to 7, distance is 8. Okay. Now, the destination nodes, V node, 1 and 7. Right? Destination node is what? Your 1 and 7. V node are 1 and 7. Right? Check the key value of 1 and 7. Check the key value of 1 and node number 7. What is the value of key value of 1 and 7? Infinite. Now, you have to check this is the condition. Weight of U to V. यहाँ पे U क्या है? U0 है, suppose V1 है, right? Source node is 0, destination node is 1. What is the weight here? 4. If weight of U to V is less than the V dot key, means ये destination node 1 है, value क्या है? Infinity. If this condition is true, if V dot key means what? 1 की key value क्या है? Infinite है, right? Weight of U to V, weight of 0 to 4 क्या है? 0 to 1 क्या है? 4. 4 is less than infinity? Yes or no? 4 is less than infinity or not? Yes. Then you have to update V dot key equals to weight of that age. So यहाँ पे मैं क्या करूंगी? ये जो infinity है ना, उसको मैं update कर दूंगी ये weight से. Okay. Every time we have to check the condition. First of all, we have written vertexes. We have assigned key value. 0 node के लिए 0 assign किया, बाकी सब के लिए infinity किया. Now, We will initially MST set is empty. We have to find out which node is having a minimum key value. 0 is having minimum key value. We will take u equals to 0. Now we have to find out the adjacent nodes of u. Means we have to find out two nodes are there, 1 and 7. Okay, two nodes are there, 1 and 7. Now what we will do, we will find the distance between 0 to 1 and 0 to 7. 0 to 1 it is 4, 0 to 7 it is 8. Now ये जो adjacent है ना 1 and 7, उसकी की वैल्यू क्या है यहाँ पे, infinity infinity. So ये जो distance है 4 and 8 वो less than है infinity से. So what we will do, we will update the key value in this table. So here I will write 4 is less than 8, 8 is less than infinity. Yes, this condition is true. So what I will do, I will prepare the table again. यहाँ पे 0 है, 1 के लिए क्या होगा 4 एंड 7 के लिए क्या होगा 8. बाकी सब अभी इंफिनिटी है. फाइन. अभी यहाँ पे ट्री भी करना पड़ेगा ना. अभी हमने क्या किया, सिर्फ 0 ही इंक्लूड किया है. ये लेवल पे अभी एमएसटी सेट में क्या है, मेरा सिर्फ 0 नोड है, राइट. सो आई विल इंक्लूड ओनली 0. नेक्स्ट, this 0 is included. The tick mark is 0 is already in the MST set. Now again repeat the same procedure from rest of the nodes 1 to 8, because 0 is already added, so no need to count it. Okay, those who are in the MST to include it. Rest of the other nodes you have to repeat the same procedure. 1 to 8, which node is having a minimum key value? 1 is having minimum key value. Okay, so I will write down u equals to 1. Find out its adjacent node. 1 के adjacent node कौन से है? 0, 7 and 2. Now since 0 is already included in the MST set, we don't have to include it again. Okay, so we will not take it. So now only two options we are having, 1, 7 and 2. So we will be 2 and 7. In MST set we will include it. First 0, then 1. Now you will find the distance between 1 to 2 and 1 to 7. What is the distance between 1 to 2? 8, and 1 to 7 it is 11. So here I will write down the distance 8 and here it is 11. अभी ये देखो, नोड नंबर डेस्टिनेशन नोड क्या है 2 and 7. कंपेयर दोनों का वेट क्या है, दोनों का की वैल्यू क्या है. 2 की वैल्यू क्या है यहाँ पे इंफिनिटी. 7 की वैल्यू क्या है 8. Is 8 less than infinity? We are going to update it. Okay. 11 is less than 8? No, so we are not going to update the value. And how you will build a tree? But you will 0, 1, or the distance 4. Now again write down the table. So I'll just copy it. So where we will do the change in the node number 2. Here what we will do, we will update to 8. So 1 is already included in the MST set. Fine. Now next step. Again repeat the same procedure. From 2 to 8, find out which node is having a minimum key value. 2 and 7, both of them are having same keys, right? You can take any node. Let me take 7 as a source node. Okay, I'll take u equals to 7. Find its adjacent vertices. 7 key adjacent vertices. Neighbor nodes of 7. 6, 0, 1, 6, 8. Since 0 and 1 is already included in the MST cell, we do not have to consider it again. So what we will do, we will take only 2, 6 and 8. Okay, so destination node here is a 6 and 8. 7 to 8, 7. 7 to 6, 1. 7 to 6, 1. 7 to 8, 7. Okay, now यहाँ पे देखो नोड नंबर 6 एंड नोड नंबर 8 दोनों की वैल्यू क्या है? Infinity, right? 1 is less than infinity, yes, we will update it. 7 is less than infinity, yes, we are going to update it. And in the MST set also we have to include 7. 0, 1, 7 is included. 0, 1 एंड 7. यहाँ पे 4 वैल्यू है, यहाँ पे 1 to 7 में क्या है? 8, राइट? सो ये यहाँ तक हो गया. अभी ये दोनों को अपडेट करना है मुझे, राइट? सो अगेन आई विल कॉपी. सो 6 एंड 8 दोनों को हमें चेंज करना है. यहाँ पे है 8, यहाँ पे क्या होगा? 1 एंड यहाँ पे है 7, राइट? Now which nodes we have included? 0, 1 and 7 is included, right? Now remaining nodes 2, 3, 4, 5, 6 and 8. Which node is having a minimum value? 6 is having minimum key value, so you will take U as a 6. So U will be 6. Again repeat the same procedure. Just this is the procedure you have to repeat for every node. Okay, now U equals to 6. 6 के adjacent nodes कौन से है? 7, 8 and 5. Since 7 is already added, no need to take it. 8 and 5. I will take 8 and 5. You just see in the MST set we don't have 8 and 5. Fine. So we will find the distance between 0 to 6 to 8 and 6 to 5. Okay. 6 to 8 distance is 6 and 6 to 5 it is 2. 2 and here it is 5, right? No, sorry, 6. 6 to 8 it is 6. Okay. Now you just see node number 8 and node number 5. What is the key value? 6 is less than 7. Update it. 2 is less than 8. Update it. Okay. Just a second. Okay. So here, what you will do in MST set, you will include this 6, draw the graph. Okay, 4, 8 and 7 to 6, the distance is 6, right? Okay, now again you will do what? You will update the table. So I'll copy the previous table. Now, in this table, node number 8 and 5 is going to update. 5 with the value 2, node 8 with the value 6. Okay, now we have included 6 and 7 in the MST set. Now remaining nodes 2, 3, 4, 5 and 8. Just a second. Till here everyone is clear what we are doing? Tell me. यहाँ तक सबको आ गया what we are doing in this example? Everyone. Till here everyone is clear or not? Okay. So let us move ahead. Now from this remaining node, which node is having a minimum key value? 5. Okay, I will take U is equals to 5. Find its destination node. 5 के destination node में क्या है? 2, 3, 4 and 6. These 4 nodes are available. 6 is already included in the MST set. No need to take it. 2, 3, 4 we will take. Okay. Now you will find the distance of 5 to 2, 5 to 3 and 5 to 4. Just remember the distance 4, 14, and 10. Okay. Node 2, 3, and 4. की वैल्यू क्या है यहाँ पे? 8, infinity, and infinity. Compare this two value. 4 is less than 8. Yes. 14 is less than infinity. Yes. 10 is less than infinity. Yes. So all these key values are going to be updated with the distance. So in our MST, we will include 0, 1, 7, 6, and 5. And I'll draw this graph. 6 and 5. That is not 5. Okay, here the weight is 4, 8, 6, and here it will be. What is the weight of? Here it is 2. 7 to 6, it is 1, not a 6. Okay, fine. So we have to update this key value. Okay. What I will do here is I'll update the key value for 2, 3, and 4. 2 के लिए क्या हो जाएगा? 4, 14, and 10, as well as we have done some changes here also for 5. Now it will be 2. Now just let me just take it. 5, 6, and 7. These nodes are included into the MST set, right? Now remaining nodes 2, 3, 4, and 8. Again, repeat the same procedure. Which node is having a minimum key value? 2. U will be taken as a 2. U equals to 2. Find out its destination node. 2 के लिए destination node क्या होगा? 1, 8, 5, 3. Since 1 and 5 is already included into the MST set, so we will take only 8 and 3. 2 to 3 and 2 to 8. 2, 2, 3, 7, and 2 to 8, it will be 2. Destination node 3 and 8 की key values check करो. 14 and 7. Is 7 less than 14? Yes. 2 less than 7? Yes. We will update it. So in MST, we will include 2. Now from 5 to, we will add 2. Weight is 4. For node 2, weight is 4. Or simply, whenever you draw the graph, you just check the above value and you just take this weight only. Fine. Now let us update the table. Node number 3 and node number 8 is going to be updated. Here 7 and here it will be 2. Okay. Now let us check which nodes we have covered. 0, 1, 2, 5, 6, and 7. These nodes are covered. Now remaining is 3, 4, and 8. Out of which one is having minimum? 8. You will be taken as a 8. Fine. Now next, you will find the destination node. For 8 destination node क्या हो सकता है? 267. Check the MST set. All of them are already included, right? So simply what we will do, when the nodes, destination nodes are already included in the MST set, you just add this node into the MST set. You simply add 8 here because no need to update it because all the nodes are already included in the MST tree. So no need to check it. Fine. You simply add 8 in the MST tree. So I'll copy here. I'll paste it. 8 node 8 is having weight 2. So this weight 2 we have updated, right? Now in this table we don't have to update because there is no change. So I'll copy it. Fine. Now you just see there is only one change, that this node is already included. Now you are having only two options, 3 and 4. Which node is having minimum key value? 3. So you will take u equals to 3. We have to find out the adjacent node of 3. Let me copy it below. Okay. So the destination node for 3, 2, 4, and 5. Since 2 and 5 is already included, right? So we have to consider only 3 to 4, right? So in MST set, let me include 0, 1, 7, 6, 2, 5, and 3. Also 8 is also included. 8 and 3, right? Now 3 to 4, what is the distance? Node number 4. Key value of node 4, that is 10. 9 is less than 10. Yes, this 3 to 4. Where is node number 3? Node 3 we have to include, that is 2 to 3. 2 to 3, which is having 7. Because last node we have included, that is 2, and from 2 to 3 we are going to include, that is 7. Okay. Now let us just do the final step. I'll update the value. Here it will be 9. This all the nodes are included, so only one choice is there. This is your U4. U equals to 4, V equals to the destination node of 4. 3, 5 already included, so no need to proceed. Simply you include 4 in the MST set. All the nodes are included in the MST tree. Okay, so final tree I'll draw here. So this is your final tree. Is 1, 2, 4, 2, 7, and here it will be 9. Okay, so this will be your final tree. Okay, and you just count the total weight. 4 plus 4 plus 8 plus 7 plus 1 plus 2 plus 2 plus 9. 37. This will be your minimum spanning tree. This is the exact implementation of Prim's algorithm, right? The previous method we have seen, that is, we can say the simple method or shortcut method we can use. So whichever you find it easy, you can use it. No, no, you can do it in your own method. First will be easy, but if you remember it properly, that you have to, yes. Otherwise, Prim's and Kruskal will be the same only. So this is the example of the actual implementation of Prim's algorithm. Is it clear, everyone?
Yes, ma'am.
The Prim's algorithm. Okay, fine. So these are the two methods. Now let us move on, and we are studying the second method, which is a Kruskal algorithm. No, I'll provide you all the materials, so don't worry. I'll provide this notes also. I have already uploaded for unit number 4 and 5. Once this unit is completed, I'll upload this lecture notes as well as the material. Fine. Four chapters. Unit number 4, 5, 6, and string matching, unit number 8. There will be total 4 units in your mid semester 2. Dynamic greedy graph and string matching. 4 units will be there for mid semester 2. I have already uploaded the material for unit number 4 and 5. Once this unit is completed, I'll upload the material for this for this chapter also. In a string matching, we are having only 4 algorithms, which are very easy. One is a bit difficult. One, you have already studied this finite automata. You have to build an automata for string matching. One is a string name matching. Like you have to match one by one each character. Once you find the position matching character, you have to return the index. That's it. That chapter is very easy. But the we can say that the most difficult chapter for you will be graph and dynamic. These two chapter will be hard for you. So start preparing from today. Okay, I have already given this instruction 2 days back. 2 days pass, so you have to manage your time. Please give 10 minute time to each question and try to solve it within this period only. Whether you are able to complete it or not. And in a assignment one, each and everyone has to write down each and every steps. For LCS, you have to calculate it for each row. It is not like that you calculate it for one or two row and that's it. No. In assignment, you have to write down each and every steps for entire example. Otherwise, you will not get the full marks. If the example is asked in a 6 or 8 marks, you have to write down at least 2 to 3 pages of an example. Then only you are able to get the marks. Otherwise, you will not get a mark, full marks. That's why I'm asking you. That's why I'm asking you to start preparing from today on only. Give the time to each example as only 10 minutes. Try to solve it within this period. Because dynamic and graph, and specifically graph, there is a Floyd-Warshall algorithm. It is taking very, very much time. It is very lengthy. So it's better you just start practicing from today. Fine. So let us start second algorithm, which is a Kruskal algorithm. Fine. Again, there is a two method, but the first method is quite easy. If you use it, then it's fine. Okay. Now, just let me just copy the. Let me explain the rules first. Let me this. Okay, so in the KRUKAL'S algorithm, what we have to do is the same graph will be given. It's okay. I'll upload this material, from that you can read. Okay, I'll read it. You just listen. First, we will begin. What we will do is one graph will be given. One graph will be given. We have to do what? We have to create a edge list for the given graph with their weights. Means ये जो graph है उसमें क्या कितनी सारी edges है? All the edges we have to write down with its weight. Like this, 0 to 1 weight is 4, 0 to 7 weight is 8. Like this, we have to prepare it for entire graph. Then we have to sort this edge list according to minimum to maximum. In increasing order, we have to sort them. Third step, we have to draw all the nodes to create a pattern of the spanning tree. We have to pick up the edges which is having a minimum weight. We will take all the edges as long as it is not creating a cycle. And another thing you have to remember is, suppose if there are 9 nodes, suppose there are 9 nodes in a graph, and you have to make a count of the edges. If there are n minus 1, that means 9 minus 1 equals to 8. If there are 8 edges in a graph, you have to stop the execution of an algorithm. Even if the even if there are some edges that is remaining, we do not have to consider it. Simply we discard it. Second thing, whenever we are taking the edges which is having a minimum weight, but it is creating a cycle, right? Then we have to simply discard it. We are not going to take it. We will move forward to the next edge list, right? So this process we have to repeat until we got the final minimum spanning tree. As long as we are having n minus 1 edges, we have to stop the execution of an algorithm, fine. So first step is what? We will calculate the number of edges in this. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. There are total 14 edges are available, right, in this graph. So whenever we are preparing a table, so first of all, what I will do, edge list, and here I will write weight. Okay. 0 to 1, weight is 4. 0 to 7, weight is 8. 1 to 7, weight is 11. We have to take only black one. Okay. 1 to 2, 8. 7 to 8, 7. 7 to 6, 1. 8 to 6, 6. 2 to 8, 2. 2 to 3, 7. 2 to 5, 4. And 3 to 14. 3 to 4, 9. And 5 to 4, 10. Okay, I'll count it. If it is pending, if it is any pending edges, then we will include it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1 is remaining, which? 6 to 5. 2. We have not included it. Okay. So there are total 14 edges. Okay, now we have to sort them. Step 1, I have to write. Step 2, sort edge list in increasing order. So again, we will do the same thing. We'll write down the edge list. Now we will sort them. Okay, which one is having minimum weight? 7 to 6, weight 1. Then 2 to 8, 2. 6 to 5, 2. Just let me copy this image. You just tell me. 0 to 1, 4. No, now there are two fours. 2 to 5, 4. Then 8 to 6, 7 to 8. 7 to 8, weight is 7. Weight also, you have to speak weight also. 0 to 7, 8. 1 to 8. Sorry. 1 to 2, it will be 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Okay, sorting is done. Now we have to build a tree. So what I will do, I'll remove this. We will take one by one each age list and we will add it into the graph. Step 3, build a skeleton. Or let's say we will build MSC, minimum spanning tree. First we will take 7 to 6 with weight 1. Okay, 7 is here, 6 is here, weight is 1. Second, this is included. Okay, next you will include 2 to 8 with weight 2. With weight 2. So this is also included. Next 6 to 5 with weight 2. So I'll join everything one by one. Here it 1, 2, 2 to 8. Here it is 2. This is also included in the MST, right? Now 0 to 1. Weight is 4. We have to check is there any cycle or not. Cycle is formed, then we don't have to take it. Okay. So this is also included. Next 2 to 5 with weight 4. Okay. Let me edit. Okay, this is also included. Now you just keep track of the count. Okay, 1, 2, 3, 4, and 5. 5 edges we have included. Now number of nodes. Here number of nodes. So edges must be n minus 1 equals to 8. जब भी ग्राफ में 8 edges हो जाए, we have to stop. Okay, we have make a count like 1, 2, 3, 4, 5 edges we have included right now. Now next is 8 to 6 with weight 6. Okay, I'll copy this graph. 8 to 6, if I'm joining, it is creating a cycle. So we are not going to include it. We are discarding it. Simply we discard it. Next 7 to 8. 7 to 8 weight is 7. Okay. 7 to 8 weight is 7. Again it is creating a cycle. So simply we discard it. Okay, so we will not include it. Next 2 to 3 with a weight 7. Okay, 2 to 3 with weight 7. This is included. It is not creating any cycle. So this age is included. Now we are having 6 ages in the graph. Next is 0 to 7. Weight is 8. Okay, 0 to 7. Weight is 8. This is included. Fine. So here we will take it 7. Now 1 to 2, 8. 1 to 2. Just a second. We have done some mistake, I guess. Yes, there is a cycle. So 2 we cannot include it. How I will show you. If you add it, here 8. If you add this, then it is creating a closed cycle. 0, 1, 2, 5, 6, 7. Right? This is a closed cycle. So we cannot take it. So we will discard it. I'll discard it. Next is 3 to 4 with weight 9. So last is 3 to 4 with weight 9. So here 4 with weight 9. So this is your final MST. This we have included, and you see the count here varies to the 8 ages. So now we will simply stop the execution of an algorithm. We are not going to include anymore. This will be simply discarded. Fine. So this is how the algorithm will stop the execution. And this is your final tree. And again, total is will be same, 37. Then, is it clear, everyone? KRUKAL'S algorithm is clear to everyone or not? What about others? I want a response from all 59 students. Okay. So let me show you the other method of the KRUKAL'S algorithm. I guess you will find it very easy. But if it is asked for 6 or 8 marks, you just write down this first method, because it will have the more pages and you will not do any kind of mistake in that. That's why. Because sometimes what happened that these algorithms are very confusing and KRUKAL'S. Right now you just see that both of them are having different implementation, but at the time of exam you will mix up. That's why I'm asking you, in a KRUKAL use this method, so that automatically you will remember in a prems that we have to take all the previously taken previously remaining ages. You have to remember this keyword. Fine. Prems you have to take previously remaining ages also. Then it will be there is no confusion in exam. Okay. And in exam I will not help you. Okay, so let me show you one another method of this KRUKAL'S algorithm. I guess you have done this method only. I'll draw the graph here. Okay, first of all. Suppose this is your graph. Okay, I'll write down the ages. Okay, this is your graph. How we will do it? Simply, I'll write down each and every node here first. 1, 3, 2, 4, 5, and 6. Now, we will keep track of this MST set. Okay. Now, we have to start with any node which is having, we have to start with the age which is having minimum weight. Which is having minimum weight? 1, 3. So I'll join this. Next, 2, 4, 6. Weight 2. Okay. Then, which node we have taken? 4, 6, it will be 2. So in MS, you will include 1, 3, 4, 6. Then 3, 2, 5. Okay, next 3, 6, 4. 3, 6, it will have a 4 weight. So simply I'll include. Now next 2, 3, which is having 5. If you take 3, 4, then it will create a cycle. So we cannot take this 3, 4. 1, 4 also we cannot take it because it is creating a cycle. So one option is there only, which is 3. So simply I'll do what? I'll add 2, 3. I'll combine this. Okay. Now any node now with 6, 2, 1, it will create a cycle. 5, 6 also create a cycle, right? So this is the end. This is the second method, right? I know this method is very easy. Yeah, it's fine. But it is better to use a first method. In a prems, I'm not saying that you use a second method, but in a this KRUKAL'S, try to use a first method. You have to get the marks, so it is better to use of this first method, right? So this is all about frames and KRUKAL'S. Minimum spanning tree is completed. In our next session, we will take algorithm. Fine. Okay, so thank you everyone. I hope you enjoyed the session.